Okay, here's an example of taking the limit of a trig function, and I will readily admit that dealing with trig functions can be tricky, and sometimes it seems like these solutions come out of magic, but it really just comes from throwing a lot of stuff at the wall and seeing what sticks. And one of the things that you need to kind of remember is when you're dealing with trig functions, we have a lot of identities to deal with, and we have a lot of kind of special rules. Things like we know that if we're taking the limit as x goes to 0 of sine of x over x, we've proven that that actually equals 1. So whenever you're dealing with limits of something going to 0 and you see a sine in there or a tangent in there or any trig function that could have a sine in it, you might want to be thinking about this situation and seeing if maybe you can use that to your advantage. And so because we have this sign at the top, we need to have a theta underneath it. So how about if you divide top and bottom by 3 theta? So you have sine 3 theta over 3 theta all over theta over 3 theta, right? Plus, well, remember, this isn't, well, we'll just do it in steps. Tangent 7 theta over 3 theta. Okay, so we know the top is going to be 1. Now we need to deal with the bottom. So let's take them in two pieces. Let's just deal with this tangent piece. So tangent 7 theta over 3 theta equals sine of 7 theta over cosine of 7 theta, right? All over 3 theta. Well, that's the same thing as sine of 7 theta over 3 theta times 1 over cosine of 7 theta. Okay, so now we're close, right? This is sine of 7 theta over 3 theta. It's really close. It's really just off by a constant. So what about doing sine of 7 theta over 7/3 times 3 theta, right? Because if we multiplied the bottom by 7/3, the 3's would cancel and we get 7 theta, and we'd have the 7 theta over 7 theta. But we have to just make sure that we do it top and bottom, right? So that's legal. That piece is okay. And now we know that, I'll do it in color, this will all become just sine of 7 theta over 7 theta, and that will equal 1. Right, and we'll be left with just 7/3. So let's put it all together so we can see it. So here's the limit, theta going to 0. On top we have sine 3 theta over 3 theta. On the bottom we have 1/3, right, because the thetas cancel, plus, and then this piece became all of this stuff, right? So it became 7/3 sine of 7 theta over 7 theta times 1 over cosine of 7 theta. Now when we take the limit, right, this is 1. This piece is 1. So we get 1 on top, 1/3 plus 7/3, right? 7/3 times 1, and then times, well, 1 over cosine 7 theta. As theta goes to 0, this becomes cosine of 0. Cosine of 0 is 1, so we just get 1 over 1. So we have 1 over 1/3 plus 7/3, that's 8/3, which is the same thing as 3/8. And I agree, these are tricky, they're difficult, but it really is just a matter of trying something and keep moving things around and keep playing around with those trig identities.